Title: How Engineers Designed a True-Face Circular Glass Elevator for a Villa. Hook: Can a circular glass elevator really have a true 3-degree unobstructed view? For many luxury villa projects, the visual goal is clear. The homeowner wants a transparent elevator in the center of a spiral staircase. The elevator should look like a clean glass tube. It should feel open, light, and architectural. But achieving that look is not only a design problem, it is an engineering problem, a FE. Story Villa project in the Philippines shows why the drive system, structure, glass, and safety design all matter. Project background: in this project, the homeowner reserved a precise circular void in the center of a spiral staircase. The goal was to install a circular glass elevator as the architectural centerpiece of the villa. The elevator needed to provide a true panoramic experience without major visual obstruction inside the shaft. At the same time, it still needed practical performance. 50 load capacity, approximately 3 persons, and a travel speed of 50. Faced created one central engineering question: how can the elevator remain visually transparent while still operating safely and smoothly across 4 floors? The counterweight problem: many elevator systems use a counterweight. In traction elevator systems, the counterweight helps balance the cabin and improve energy efficiency. But for a circular glass elevator, the counterweight can create a visual problem. The counterweight needs its own running space. It also requires guide rails and structural support inside a circular panoramic shaft. These components can block the view and reduce the clean glass tube effect. So if the design goal is a true 3-degree view, the counterweight becomes a major architectural limitation. That does not mean traction systems are bad. For many projects, they are practical and efficient. But for this specific villa project, where the main goal was an unobstructed circular panoramic appearance, a counterweight-based layout was not the best fit. Forced drive system to solve this. The elevator used a forced drive system, also called a positive drive system. The main advantage in this case was that the system did not require counterweight. By removing the counterweight and its related guide structure, the elevator shaft could remain much more visually open. This made it possible to create the 3-degree panoramic effect the homeowner wanted. However, removing the counterweight also changes the engineering requirements. A counterweight-free system must still support stable motion, load capacity, and controlled operation, so the design included a reinforced chassis and a carefully matched drive motor configuration. This allowed the elevator to maintain 3 speed and 3 kg capacity while keeping the circular glass shaft visually clear. The lesson is simple. For a 3-degree circular elevator, the drive system is not hidden from the architecture. It defines the architecture. Circular frame and glass design. A circular panoramic elevator also needs the right materials for the framework. The project used custom extruded, one-piece molded aluminum alloy frames. Compared with a more segmented or welded visual structure, this helped create a smoother and cleaner exterior appearance. For both the shaft and cabin, the elevator used double-layer, laminated curved-tempered glass. Curved glass is important because a circular elevator cannot rely on flat panels if the goal is a continuous glass tube effect. The glass must provide visual clarity, structural strength, and safer breakage performance. So the appearance of the elevator depends not only on transparency, but also on how the glass is formed, laminated, and integrated with the frame. Safety and emergency systems. Even when the elevator is designed as a visual centerpiece, safety cannot be secondary. This project included an ARD or automatic rescue device. If a power outage occurs, the ARD activates automatically. The elevator moves to the nearest floor and opens the doors, so passengers can exit safely. The control panel also included a SIM-enabled SOS dialer. In an emergency, passengers can press the SOS button and make a direct cellular voice call for assistance. This is especially important in private villas, where an elevator may be used by family members, guests, elderly users, or children. The system also included the Smart Eco mode. When the elevator is idle, lights, fans, and displays turn off automatically when called. The system reactivates. For a home elevator that may remain unused for long periods, this helps reduce unnecessary energy use. Conclusion: this Philippines project shows that a true Fay-degree circular glass elevator is not only a visual design, it depends on drive system selection, counterweight layout, structural stability, curved glass engineering, and emergency safety design. In this case, the solution used a counterweight, free-forced drive system, reinforced chassis design, one-piece, molded aluminum alloy frames, Fay-laminated curved tempered glass, ARD automatic rescue, SIM-enabled SOS calling, and smart eco mode. The result was a circular home elevator designed for a Fay-story villa with a Fay cage capacity, Fay speed, and a more open panoramic view inside the spiral staircase. For more details about this Philippines Fay-degree circular glass elevator case, you can read the full project article here. https://faylift.com Fay-degree circular glass elevator Philippines case Fay